So frequency reuse. Why frequency reuse? For the efficient spectrum usage for radio communication system, we are using frequency reuse purpose. Example, suppose each user is allocated a channel and each channel have a bandwidth of 25 kHz to enable sufficient audio quality to be carried, as well as enabling there to be a good band between adjacent channels to ensure there is no interference. Using this concept, only possible to accommodate 40 users in a frequency band of 1 MHz and 4000 users in a frequency band of 100 MHz wide. Today, cellular systems have millions of subscribers, and therefore a far more efficient method of using the available spectrum is needed. The method that is employed is to enable frequencies to be reused. So here each cellular base station is allocated a group of radio channels with a small geographical area called a cell. The neighboring cells are assigned with different channel groups. By limiting the coverage area to within the boundary of a cell, the channel groups may be reused to cover different cells. Keep interference level with tolerable limits. Because of only a small number of radio channel frequencies are available for mobile system, engineers had to find a way to reuse the radio channels to carry more than one conversation at a time. The solution adopted by the industry, that was the frequency planning or frequency reuse concept. In this concept is based on assigning to each channel a group of radio channels within a same geographical area. Cells are assigned a group of channels that is completely different from neighboring cells. The coverage area of a cell is called the footprint. The same group of channels can be used in different cells that are far enough away from each other so that the frequencies do not interfere. This is called frequency reuse, and the reuse distance is RC root n, where RC is the range that covered by the base station and n is the number of cells in a cluster. So here the concept of frequency reuse is illustrated in this figure. Here we are considering two clusters, cluster 1 and cluster 2, and each cell have different frequencies in cluster 1, F1 to F7, and that same frequencies that is used in cluster 1 is used in cluster 2 also, F1 to F7. And here F3, two clusters, you can see that here F3 and that same frequency reused in cluster F3, cluster 2 F3 has a certain distance, that is reuse distance, that is represented in that figure, and RC denotes that range that that base station can cover. There are some advantages for using the frequency reuse. You know that many transmitters of same output power operating at the same frequencies can be used. It reduces the minimum height of the transmitting antenna, and it has some disadvantages. The main disadvantage is that co-channel interference can occur if the system is not properly designed. If we are not properly arranging the frequency reuse, if we are not properly using the frequency reuse concept, there may co-channel interference can occur. Co-channel interference, it is a phenomenon in which two frequency signals of adjacent channels interfere each other. It is called co-channel interference that may happen. Thank you.